We're looking at calculating the area of irregular shapes. So what is an irregular shape? First thing is, let's look at an irregular shape or regular shape. This is a regular shape. This is a rectangle. This is a regular shape. Shape whose dimension and whose properties are known, we can term it as regular shape. Irregulars are something like this, weird, once in a blue moon picture. All of these are irregular shape. This too is a irregular shape. If I draw something random, that's a irregular shape. So we are trying to figure out the area of such structure. So basically, in all of this, we are going to guess the value. How? We'll follow certain rule. Okay, so we will use certain set of rules to do this. And that rule is over here. The rule can vary, but for you guys, for now, the rule is this. The rule is that you have a graph sheet of paper on a regular shape. For example, over here, right? The structure is supposed to be just this, but I placed a graph paper on that. So we need to do that first. And then what? Then start counting. Counting what? Counting the squares. So the area of one full small square is taken as 1 square unit. Ignore the area of that are less than half a square. If more than half, count it as 1. If exactly half, count it as half. Let me explain it with this example. I have a irregular shape. Imagine that this dot dot structure is your square grid or a graph paper, right? What I'll do is I'll count how many full square the structure is occupying. For example, this is one full structure. This is another full structure. This is another full structure. This is half and this is half. So this is 1, 2, 3, half and half. Half and half will give me 1. So this is basically 4 square. Say this is in centimeter. Okay, so this structure is 4 square centimeter. How did I find that? I started counting how many square grid or square shape the structure is occupying, and I was able to figure it out. Right? I basically used the first and the fourth one. Second and third I have not yet used over here. Let me use that. So actually, let me take a screenshot, which I already have. Let's make use of that in this structure. So first is to do with the area of full small square is taken as 1 square unit. So let's see how many full are there. So this is full, 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 kind of full, full, full. This is also kind of full. This is also full. This is also kind of full, 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 full. Okay, right? I think almost full scenarios I have considered, right? The first one is considered. Next, ignore the portion of the area that are less than half a square. So let me do that. So this is half, less than half. So ignore that, ignore that. Then what else can I ignore? So this I can ignore, this small space, ignore, ignore. This is a bit more than half. This is more than half. This is more than half. This is less than half. Ignore. This is less than half. Ignore that. This is kind of more than half. This is also kind of more than half, more than half, more than half, less than half, less than half. Yeah. Less than half, less than half, more than half, more than half, more than half. Okay. So I ignore the less than half. So next step is, if more than half, it is to be considered as 1 square unit. Okay, so for example, this is full. This is considered, we can consider as full. This is full. This is full, full, full. This is not, this is kind of, this is a bit more than half, but I'll consider this as half. So I'm making use of the third rule. if exactly half. So I'm making use of that. So this I'll consider as half. This is full. This is kind of full. This is also full. This is also full. This is also full. This is kind of half, right? And done. So now all I have to do is count the full and half. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 plus 2 halves, so 25. So this is 25 square. If this grid is of centimeter, right, each of this is 1 centimeter, I can write it as square centimeter. If this was meter, this is meter. Now, if this was 1 meter, this would have been square meter. Okay, so I'll just take it as centimeter, so it's easier. Or I can just go with unit. If I don't know if it's centimeter, meter, I can just write unit. Okay, anyways, let me explain what I did over here. What we are looking at is known as an irregular shape. At the opposite end, we have something called as regular shape. So how did we go on to figure out the regular shape area? Here too, we made use of counting the number of square tiles that can occupy this particular structure. Because it's regular, the math, using multiplication, addition, subtraction and all of that, we can use certain math and we can figure out the area. But when it comes to irregular shape, we can't do that. There's no multiplication or division, or we can't use a particular formula to figure out. But instead of that, as a replacement, we have a methodology. What is that methodology? What is the methodology about? Well, given any irregular shape, place a graph sheet of paper on that and count the square grids. The rule is quite simple. If it occupies the entire square, right, like over here, just count it as 1. If it's less than half, ignore it. If it's more than half, count it as 1 again. If it's exactly half, count it as half. Okay, again, this is quite simple rule. Let me make use of it again. So you can pause and do it yourself, guys. I mean, you might not get what I will get, but try it. Okay, let's do this. So this will consider as full, 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 full. I'll stop telling full because my throat will pain. So this is perfectly full. There's nothing to discuss over here actually. All these are perfectly full. Yeah. Next step is to count ones which are more than half. Okay, example over here. We'll consider this as full. More than half, this we'll consider as full. This is to be ignored. This is full. More than half, we'll consider as full. Full, not more than half, not more than half. This is full and this is also full. This is kind of half. This is less than half. This is more than half. So all these are considered to be full. Now, things which are less than half should be ignored. Exactly half should be considered as half. And more than half, yeah, we already considered. So this is it kind of half? It's kind of half. This is kind of half. This is, yeah, this is also I can consider it as half. I want to consider it as half. This is almost half. These two combined can give me 1. So I can do that. This is ignored because it's less than half. This small thing also can be ignored, less than half. This is half. This is exactly half. Less than half, ignore. 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 This, if I make it, push it, this can be half. This, if I redistribute, can be half. This is half, clearly half. And this is to be ignored. And now all I have to do is count it. That's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 full. Not to forget that. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 half. Again, not to forget. 10 half. So 10 half is nothing but 5 full. So basically you have 24 plus 5, that is 29 square. Since I don't know if it's centimeter, meter, I'll just write it as unit. Square unit. Okay guys, this is the entire procedure. Right? I have few more example over here. I can pause it for you guys. You guys can figure it out. Okay, I'm not going to do that. So what is that we are doing here? We are looking at something called as irregular structure, which are not your square or rectangle or triangle and all of that. So we are trying to figure out the area of such structures. How do we do that? We make use of, for example, say a square paper. Graph paper. So place a graph paper over that. Count how many full small square it is occupying or can fit into that. Ignore the ones which are less than half. Things which are exactly half, count them as half. Things which are a bit more than half or a lot more than half, count it as entire unit. And once you count all of that, whatever answer you get, it is a closer answer. It's not an exact answer. It's a rough estimate. It's a answer is exact area is closer to that value is what we are trying to tell. It's not an exact answer. It's a very approximate answer. That's another way of expressing it. Approximate. Approximate means it's kind of close to it, but it's good enough. Right? What we are doing here is figuring out an approximate answer. Okay. So you guys can practice on this. Practice with your friend or someone who can help you out. So sit and practice with them. And if you guys are interested looking at it, yeah, you can have a look.